Good morning, one and all. I am Dr. Ramya Swetha, Assistant Professor, Department of Civil Engineering from Institute of Aeronautical Engineering. Today, we are going to discuss about what kind of model question paper, there is a chance in our examination. So, as per our UG 20 regulations in our question paper in Institute of Aeronautical Engineering, the module 1 and 2 are compulsory questions. From module 1 and 2, there is no choice from 1 and 2. The remaining modules 3, 4, 5, there is a choice, internal choice between modules. From module 3, we have two different questions. In that we have to answer one. 1A, 1B, 2A, 2B are there. So we have to answer one question. So each question carries generally 7 marks. They are going to split, actually 14 marks. So now they split into A and B, or C also there is a chance, like that the question paper is there. So now we discussed about the what type of questions there is a chance in come in our examination for this ground improvement techniques. Till now, what we understand overall theory, what kind of possibilities of problem solving, what kind of different question bank from each modules, what kind of questions they may ask, what are the various definitions and terminologies involved in these ground improvement techniques, what are the various case studies involved in this ground improvement techniques. We understand all these things in our previous lectures. In this lecture, what we are going to conclude is what are the model question paper. What is the model question paper in it? So now, model question paper consists of 5 modules. From module 1, there is no chance of multiple choice. We have to attempt. Similarly, module 2. Coming to the module 3, we are going to, there is a choice within the module. Now, we understand this is the question paper 1A, 1B, 2A, 2B, and 3A, 3B, 4A, 4B, like that. These are the questions generally we will get. 1A, 1B, there is no choice between. We have to attempt 1A and 1B and 2A, 2B. In this 3, there is an internal choice between. So, we may have 3A, 3B or 4A, 4B. Within one question is enough. From 4 also, one question is enough. Similarly, 5. These type of questions we have. So, what kind of questions, how we are understanding? In this module 1, there is a chance of question like this: define ground modification. Define ground modification and explain its significance in civil engineering process. We may write as per our knowledge till now what we understand. Coming to the ground modification, define ground modification. It is nothing but the ground improvement. Modification is nothing but the improvement. It means sometimes we may reduce plasticity getting the better results. So it means it is not improvement, it is improvement in terms of strength point of view. Like that we have to understand. So modification, whether we are increased the property value, decrease that particular property, even though it gives the desired property for the construction work. Like that we have to understand the things. So here, define ground modification and explain its significance in civil engineering projects. So, the ground modifications may require in n number of different ways. In agricultural point of view, in different it is there, but as per civil engineering projects, they are asking. This is the clear. Now, how we are going to write it depends upon the how many marks. Whether it is belong to 14 marks, 7 marks, 2 marks, 5 marks, depends upon that we have to enlarge the answers. So now, for example, it is for 7 marks. Now, we understand define ground modification is for 2 marks, 2 to 3 marks, remaining for explanation, the importance in civil engineering project. So, for example, that is the key for the question. Now, how we are analyze? in define ground modification. It is also known as ground improvement. Already we discussed decreasing one properties. It means it is not reducing that. Reducing the property means it gives the better strength or better safety point of view or required project requirements it is going to fulfill. In that perceptive we are understanding it is comes under ground improvement. Here ground modification is also known as ground improvement. So refers to set of engineering techniques used to enhance the physical properties of the soil to meet the requirements of the construction project. So this is nothing but the definition of ground improvement. We may write in different ways. We may enlarge these. What are the physical properties involved in this? We may write density, permeability, strength, stability, slope point of view, stiffness. So many parameters are involved, and also the shear strength, load bearing capacity, these are all various physical properties. You may write few more as per the convenient. So we may explain like this also. Enhance the physical properties of soil, mechanical properties of soil. Those are, for example, like that you may express in your own way. So here we may write like this. Few are there. You may in term moisture content, these are all we may write. Like this we may write of the soil to meet the required construction project. It may highways, buildings, bridges, ports, tunnels, any type of huge construction. So many infrastructures. High-rise buildings, school buildings, commercial buildings, hospitals, any kind of infrastructure, airports, bridges, railway stations, like that we are going to understand. So any type of construction work. So like that we are going to define the ground modification first, and we may express in any way like this. And now after these once we done the definition of the ground improvement techniques as per the marks, we have to analyze and what we understand. This is also known as ground improvement. We are going to define ground modification is nothing but it is also known as ground improvement, a set of engineering techniques. Whenever we are using some techniques, we may use these techniques also. What kind of techniques? Whether they physical modification, chemical modification, mechanical modification, hydraulic modification. These are all we may kept according to the given question as per the number of marks we are going to understand. So now this ground modification is also known as ground improvement, refers to a set of engineering techniques. Those may physical, chemical, mechanical, hydraulic, and by confinement, by admixture, so many parameters. So in so many ways used to enhance the physical properties of the soil to meet the requirements of the desired properties, or to meet the desired properties of the construction work. In your own words, like that we are going to construct, framing the words and complete the sentence in meaningful way. Now Once we are going to define the ground modification, now move on to the significance. What is the importance in civil engineering projects? We may consider civil engineering projects in different number of civil engineering projects. Those are bridges, buildings, infrastructures, port construction, tunnels, airports, runways. So many are there. Industrial structures, commercial buildings, where that particular locality is there. These are all the construction projects we are going to consider. What is the significance? This ground modification is significant in civil engineering as it enables the safe and efficient construction of structures on soils that would otherwise be unsuitable for supporting heavy loads and enduring long-term use. For example, any sort of port or airports, any kind of tunneling work we are going to done in those soil properties are not suitable for such type of construction, even though the construction must be done. For example, dams, reservoirs, so many are there. So, but we have to construct there only but the soil properties are not suitable for these conditions. In that particular, we are using these ground improvement techniques for getting the desired properties of the soil as per the requirements of the construction work. Like that, we have to express in your own way. So, this kind of expression for given based on the marks, we are going to expand our solution, our writing part. So, this is the overall view of this particular question. Define ground modification and its significance in civil engineering. And next, discuss the different classifications of ground improvement techniques and the factors influencing the selection of particular method. So, these are the discuss different classifications of ground improvement techniques and the factors influencing the selection of particular method. It means what are the different classic types of ground improvement techniques are classified. This is nothing but the types of ground improvement techniques. Factors influencing the selection of a particular method. Factors influencing the particular method. So, how we are choose? We have and different number of modifications are available, different techniques are available. How we are going to choose? So, here first we have to discuss the classification of ground improvement techniques. As per the condition, different techniques we are going to categorize the ground improvement techniques. Those are mechanical modification, hydraulic modification, physical and chemical modification, thermal modification, modification by inclusion and confinement. These are the various types of modification. In this comes under mechanical modification techniques like dynamic compaction, vibro compaction, stone columns that enhance the soil density and strength through physical means. Here those properties are soil density and strength. Move on to the hydraulic modification methods such as preloading, vertical drains that control and manage groundwater conditions to improve the soil properties. Here the name itself tells on which type of category it belongs to. And also physical and chemical modification techniques like lime stabilization and cement stabilization, which alters the soil chemical composition to improve the engineering properties, alter the chemical composition. In thermal modification, use heat to stabilize soil, often applied in special conditions like high temperature industrial sites or cold regions. Heavy cold regions, heat, high temperatures and low temperatures, the variations occurred in that particular, we are going to use these kind of thermal modification. And modification by inclusion and confines involves using geosynthetics, stone columns or similar inclusions to reinforce soil and improve its load bearing capacity. So here In this classification and what are the factors involved in that particular is together we are going to understand in this particular one. So here mechanical modification is by means of the physical modification under mechanical properties. Based on the mechanical properties, we are going to understand these mod techniques. So here those are dynamic compaction, vibro compaction, stone columns. They are for those mechanical properties. Those are density and strength. Coming to the hydraulic in terms of water. So whenever the groundwater conditions are different, to control that and manage that groundwater to improve the soil properties, we are using these kind of category, that is hydraulic modification. In that method, preloading and vertical drains are there. Those techniques we are use. In physical and chemical, we are going to change the soil chemical composition. So in terms of physical techniques and chemical modification, those techniques like we are adding some admixtures, chemicals to change the composition of the soil for getting the engineering properties. So and next move on to the thermal modification. Use heat to stabilize the soil special conditions. Whenever the high and low temperatures are there in that particular, we are using these kind of thermal modification. Whenever we are using geosynthetic stone columns to reinforce based on the load bearing capacity properties, we are going to choose required load bearing capacity improves and reinforcement is required for the soil. Such type we categorize this modification by inclusion and confinement. We use those techniques for getting this improvement of the load bearing capacity, and also whenever it requires the reinforcement to the soil. Like this we are going to categorize. And also how we are influencing the selection of ground improvement method. So according to the based on the soil type, whether it is clayey soil, sandy soil, loose soils, how the technique is respond, and also the load requirement, soil type, loads, heavy loads or moving loads, what kind of loads are there, how the structure is going to influence. According to this, we are going to understand the project scale, whether it is large scale, small scale, that also important for choosing the technique. Environmental impact, how it environmentally impact or environmental concerns also very important. According to the regulations and the environmental acts, we are going to understand, and also the cost effectiveness and the how much time it is going to take that particular technique for getting the desired property. So based on the soil property, based on the required or desired property, we are going to choose the technique. For getting this desired property also, we have to understand the soil type. Different soils respond differently to various techniques. And also load requirements. The load bearing needs of the structure influence the method of choice. In project scale, large scale projects might require different techniques compared to the small ones. In environmental concern, some methods are more environmental friendly than others. So we have to choose, and also the regulations are there, environmental acts are there, we have to obey those, and then we choose the technique for that particular locality. It depends upon the where the site is, what kind of soil properties are required for project. These are also important for understanding this. And also the cost effectiveness. We may choose one technique, it is very easy, but the small scale, the project is very small scale in cost point of view. We choose that technique means it affects the project economy. So in that particular thing, we have to choose another type, another technique also. So it depends upon the cost and time also. The budget and project timelines can constrain the choice of ground improvement techniques also. These are the factors which are going to influence in this particular question. So what kind of different classifications are there? What are the factors influence? And now move on to these kind of technique, that is describe the principles of dynamic compaction. Not only dynamic compaction, any type of technique like this is one sort of model question only. So describe the principle of dynamic compaction and its application in highway construction. Include any case study from India in your explanation. So here what they ask, it depends upon the marks. Again, mark splits. Principle of dynamic compaction for 30 marks, 30 to 40. Application in highway construction, 20 to 30. In that particular case study, it depends upon 30 to 40. Like that, the percentages. So this is for 30 to 40 percentage. They may consider at the time of whenever they are preparing the key, and applications also 20 to 30, and this is for 30 to 40%. So like that they may split. So now we are understanding this principle. Not only here, this technique is for understanding only. We may get any other type of technique. Describe the principle of any X technique and its application in different construction. This is also may change. Case study in your explanation, this may possible. So these two may vary. But even though how we are expressing. So here, what kind of technique involved in this particular dynamic compaction? Before that, we may write definition of this dynamic compaction also. What is meant by dynamic compaction also, we may write nothing wrong. Then we may write about that principle. Not only this dynamic compaction technique, any kind of technique, we may write about that. What is the technique? What kinds? And later we know how, which principle is involved in that. Now here, this dynamic compaction involves the repeated dropping of heavy weights from a significant height to compact the loose and granular soils. Any type of technique, the process is there. In some of the techniques, they are going to driven, we are going to insert it. In some of the technique, we are adding something, add mixtures like that, we are adding some material. So the process, what is involved from significant height to compacted granular soil. The impact energy generated by falling weight densifies the soil and increases the bearing capacity and reduces its compressibility. What it is going to affect? Here, this technique we will write in terms of the technique. What technique it is? It is dynamic technique. How it involves? Because of these heavy weights from significant heights, type of soil. We have to mention what type of soil. That impact energy, what we'll get from this. What type of process generated by falling weight, how it will get, and soil properties, what kind of soil properties affected, improved. Like this, we have to write the any kind of technique, whether it is adding. So we are adding, because of this the soil composition is going to change. That way these properties are enhanced. For example, we consider not only dynamic compaction, we may come with vibro compaction. For other, not only for this particular case, we will consider vibro compaction for better understanding. Vibro compaction, because of introducing these vibro compaction with vibrations, the friction between the soil particles, this is loose soils. Here also the loose and sandy soils. I am writing for this vibro compaction. This is the same technique. The technique is vibro compaction. Here the technique is dynamic compaction, just for understanding purpose. Dynamic compaction. Because of vibro float. This is heavy weight. So type of soil is here is the loose granular soil. Those are sandy soils. Vibro compaction. Because of this vibro compactions and this cavity is formed and compaction will happen. Finally, I am writing about compaction. We may write we are going to fill something because of the compaction. Friction, because of the friction is involved, we are going to reduce the friction between. So compaction. Here soil properties include is that is compaction. So because of this compaction, we may write like this. This because of this we may friction between, less the friction between, reducing the friction between soil particles. So the compaction is happened. Because of this compaction, density of the property of the soil density is increased. Here it is densifies the soil also. Here also this is densifies the soil. What type of property is going to affect? Like this we have to write any kind of technique. Like this we are going to analyze the principle. So based on the process, what kind of process involved, on the which type of soil, and what is the effect is going to happen. Finally, what type of property is going to improve. Like this we are going to understand this in this particular dynamic compaction. So, and how we apply in highway construction. So case study and both are same. That's why I'm writing like this. We may write in highway construction separately and case study separately. It depends upon the how they will ask. Here in the the both in same highway. This Yamuna Express is nothing but highway. I am writing in one way. But in examination point of view, write application in highway construction. Because of the land loose sandy soils, we are applying for getting the uniformity of the densifying the soil and getting the bearable load bearing capacity whenever the heavy loads passing on to the highways, and reduces its compressibility. Like this. Now this case study Yamuna Express Highway. The Yamuna Expressway project employed the dynamic compaction to improve the subgrade soil, which consists of loose fills and safety soils. Heavy weights up to 20 tons were dropped from heights of around 20 meters to densify the soil. The process was repeated across the site, leading to the improved load bearing capacity and reduced the settlement potential, crucial for support the high speed traffic on the expressway. Like this we are going to analyze this kind of questions. Now describe the principle. Already we expressed this like this. Now explain the concept of vibrocompaction. So design vibrocompaction process layout for a sandy site considering parameters such as depth, grid spacing and compaction energy. In this vibrocompaction improvement technique that densifies the loose granular soil by inserting the vibro float into the soil. The vibrations cause the soil particles to rearrange into a denser configuration, thereby increasing the soil densities and the shear strength. So what kind? The concept or principle, whatever it may be, this is the same. Now design a basic vibrocompaction process. So the first one is how we are going to design the process. Depth of treatment, grid spacing, compaction energy are the, so few are there. Site assessment, we may write the like site, type of soil. These are also may involve in this. So according to this design of vibrocompaction process layout, the depth of vibrocompaction depends on the thickness of the loose sandy layer, typically ranging from 10 to 20 meters. How much depth it involves in the vibrocompaction. The grid spacing compaction is typically 2 meters depending on the required improvement, and it depends upon the soil condition. Throughout the area, the soil conditions may not be same. It is going to differ. According to that, we are going to choose how much spacing between the grid. The compaction energy, the energy applied throughout the vibro float is determined by the soil type and the desired level of improvement. For loose sandy soils, high energy compaction with a power unit around 120 kilowatts might be required. So like that we are going to explain. Now explain the process of preloading and vertical drains as hydraulic modification technique. Discuss their application in soft soil stabilization. In this, preloading involves placing temporary loads on the ground to accelerate the soil consolidation. So why we are choosing this preloading, that particular property we have to highlight. So here for preloading technique we are using for getting the accelerated the soil consolidation. That property, highlighting the property is very very important. Consolidation and settlement before construction. Settlement before construction is the technical terms which we are going to use. The using technical terminology very very important at the time of execution of the examination. This technique is particularly effective in on which type of soil? It's very very important. Particular technique, what kind of soil? So here the type of soils is soft compressible soil like clays. These vertical drains, prefabricated vertical drains or PVDs, are installed in the soil to expedite the consolidation process by providing drainage paths for excess pore water pressure to dissipate more quickly during pre-loading. Application in soft soil stabilization. So here asking about soft soil stabilization, other may ask. Here, the spray loading combined with vertical drains is commonly used in highway and embankment construction projects on soft clayey soils. For example, we may give any example, otherwise no need, we may explain. So here I am giving example. The NH8 expansion project in India is an example where these techniques were employed to improve the subgrade strength and reduce post-construction settlement. Like that, we are going to enhance. In this, calculated the expected settlement reduction and the time required for consolidation when using pre-loading with prefabricated vertical drains, PVDs, in clayey soil site. Use assumption based on the standard practice. So, to calculate the settlement reduction and time required for consolidation, one must consider the initial void ratio, consolidation coefficient, and the thickness of the compressible layer. Assuming those typical values, thickness of the compressible layer is 10 meters, initial void ratio is 0.8, coefficient of consolidation 0.28 meters per year, pre-loading pressure is 50 kPa, time factor for 90% consolidation, that is equal to 0.848. These are the data. Now, the time 90% consolidated can be estimated using the formula, that is equal to CVT into T by H square. And here time is required and H is the drainage path. And the final settlement S is equal to coefficient and H into delta E by 1 plus E naught. Here Cc is the compression index, H is the layer thickness, delta is the change in void ratio. Now finally we will get the answer. Calculate these things and we will get the answer. Now compare these kind of formulas we have to remember. Final settlement and 90% consolidation time. These are the things we have to understand. Now compare and contrast live stabilization and cement stabilization. Both are chemical modification technique, including example of their use in Indian infrastructure project. First, we are going to understand the lime stabilization. It involves mixing lime into clayey soils to reduce plasticity and increase shear strength through pozzolanic reaction. Best suited for highly plastic clays. In NH8 Delhi-Jaipur highway expansion used lime stabilization to improve subgrade strength. Cement stabilization involves mixing cement with soil to create a cementitious matrix, enhancing the strength and reducing permeability. Suitable for wide range of soil types, including silts and sands. Example, the use of cement stabilization in the construction of rural roads in India, enhancing the durability of low-cost pavements. So, these are the examples and these are the individually we are understanding these lime stabilization and cement stabilization. Comparison between these two, lime stabilization is more effective in treating clayey soils with high plasticity. It is more effective in treating clayey soils with high plasticity, whilst Cement stabilizer versatile can be used in various soil types. It is limited to the clay soils and high plasticity, that is lime. Coming to the cement stabilizer, it is versatile and used in various soil types. Lime is typically cheaper and better for highly plastic soils, whereas cement is provides stronger and more durable stabilization for broader range of soils, but it is little, whenever compared to the lime, it is costly. Compared to lime, it is costly. Now, one more question, that is design a lime stabilization process for a highway expansion project. Consider soil properties, lime content, curing time in your design. So design consideration: soil properties, lime content, mixing and compaction, curing time. Assume clayey soil, type of soil, that is clayey soil, with plasticity and initial moisture content of 20%. Initial moisture content of 20% and dry density 1.6 gram per centimeter cube. Lime content typically ranges from 3 to 5% of lime content. By the dry soil is used for highly plastic soil. A lime content here 5% is assumed. Mixing and compaction: the lime is mixing soil using rotary mixer, ensuring uniform distribution. The soil lime mixture is then compacted using a sheep's foot roller to achieve maximum density. The curing time: the compacted soil lime mix is allowed to cure 7 to 14 days depending on the ambient temperature and moisture conditions. So these are the things we are going to design for this process. Now discuss the role of geosynthetics in ground improvement, particularly in slope stabilization and embankment reinforcement. These geosynthetics, including geogrids, geotextile, geomembranes, plays a crucial role in ground improvement by providing reinforcement, separation, filtration, drainage. By providing reinforcement, separation, filtration and drainage. And this slope stabilization, geogrids and geotextiles are used to reinforce the slopes by providing tensile strength, preventing soil slippage, enhancing the slope stability. Example: Bangalore-Mysore infrastructure corridor, whereas geosynthetics were employed to stabilize unstable slopes prone to landslides. In this embankment reinforcement, geogrids reinforce embankments by distributing loads and preventing settlements. Geotextiles separate the embankment fill from the subgrade, preventing intermixing and preserving the structural integrity of the embankment. In this, one more kind of question there is a chance in our examination, that is design a geosynthetic reinforcement plan for an embankment of soft clay. Include considerations for geogrid selection, placement and expected performance improvements. In this design consideration, soil condition, geogrid selection, placement, performance improvements are there. Here, the soft clay with low bearing capacity requiring reinforcement to support 5-meter high embankment. Geogrid selection: a high strength biaxial geogrid is selected to provide adequate tensile strength in both longitudinal and transverse direction. Placement: geogrids are placed in multiple layers within the embankment, starting at the foundation level and spaced vertically every 0.5 meters. The geogrids extended beyond the embankment stall to anchor the structure and prevent lateral spreading. Performance improvements: the geogrid reinforced embankment is expected to exhibit reduced settlement, improved load distribution, and enhanced stability, making it suitable for supporting heavy traffic loads. Explain, and one more question, explain the use of stone columns as a ground improvement technique, discuss their advantages, limitations, and typical applications. These stone columns are vertical columns of compacted gravel or crushed stone installed in soft soils to improve their bearing capacity, reduce settlement, enhance the drainage. So any type of technology, what kind of technique we are choosing, in which properties are going to improve, we have to write in our examination. For example, consider these stone columns. So once we consider ground improvement technique as stone columns, what are the properties are going to change? Those are bearing capacity, it is going to enhance and reduce the settlement and enhance the drainage. We have to understand all these properties. In this, like this, we have to write. Here stone column is there. In any other, we have to write like this. Type of soil also. Mention type of soil. Advantages: increased bearing capacity, reduced settlement, improved drainage. Stone columns improve load bearing capacity of soft soils by creating a composite material with higher stiffness. Reduced settlement: the column reduces overall settlement by sharing the load with the surrounding soil. Improved drainage: stone columns enhance drainage, accelerating consolidation in soft soil. So what are the advantages? We have to write like this. Based on the properties also, we may write these advantages. In limitations, what type of soil? All kind of techniques may not suitable for the all types of soils in most of the techniques. So that we may write in our limitations as a first point. It is not suitable which particular soil we may mention. Here it is not suitable for the stone column point of view. We have we may use any kind of technique. What it is not suitable for all types of soils or not for increasing all sort of properties point of view also, it is not going to impact all kind of soil properties. We may highlight that particular technique. Here that is soft coil. In some other technique, it is may not be suitable for some other type of soil, or it may not affect the property. So it's that efficiency is not that much. So in extremely soft clays, the lateral support provided by the soil may be insufficient to prevent column bulging. So in this limited depth, stone columns are generally effective up to 10 to 20 meters. These applications used in the construction of foundation for buildings, abutments and bridge abutments on soft clays. For example, construction of warehouse foundation of soft clay in coastal areas of India. Like that, we are going to understand the things. In this, develop a stone column designed for improving the bearing capacity of weak soil foundation for multi-story building. Include details on spacing, depth and material selection. Design considerations: weak clayey soil with an undrained shear strength of 25 kPa. Column spacing: stone columns are typically spaced 2 to 3 meters in a triangular or square kit pattern. For this project, 2.5 meter spacing is chosen to ensure adequate load distribution. The column depth: the stone columns are designed to prevent the weak soil layer, typically extended to a depth of 10 meters. Material selection: crushed stone with a particle size of 20 to 40 mm is used to form the columns, providing high permeability and compressive strength. The stone columns are expected to increase the bearing capacity of the foundation soil to support multi-story building, reducing the settlement and enhancing the stability. Here, what we understand, what type of soil, process which one involved, and what kind of result we are getting. These are the things we have to involve based on this particular thing. So like this we are going to understand this kind, like this we are going to get these questions from various module, 5 modules. So as per IARE Institute of Aeronautical Engineering, the module 1, there is no choice from these two. From module 3 to 5, internal choice between modules. Internal choice, we have to attempt one question. In that there may be 2 to 3 sub questions may there. So like this there is a chance of questions, model question papers are like this. So thank you. We will see in our next class.
Like, share and subscribe. Hit the bell icon for more updates.